node, right? Yeah, so thanks. I'm Jonas. I'm the founder CEO of Aleph Alpha. I'll show mostly Magma, but also basically how that relates to our work with alignment and world models. And I'm really looking forward to the conversation there. I included some hypotheses where it's not super clear whether like what the correct path is, and I'd love to have your ideas and maybe your experience on that. Yeah, so kind of you've all seen that chart. Basically, this is the speed in which size is accelerating, compute is accelerating on model, right? With every tick here being 100 times more compute. There are some trends that are a little bit against that, right? So like GPT-4 will most likely have not 100 times more parameters than GPT-3, but like Palm recently showed that, yeah, maybe size is not everything, but it seems to be an important ingredient into some of the transformative capabilities. And of course, like on a practical note, this is of course difficult. This is difficult because it's expensive. It's also difficult because it's hard to do, and it is a different kind of skill than the kind of more like science perspective. So typically, in order to train these kind of models efficiently, not only do you need a lot of money, but you also need to combine different skill sets that like this alone is difficult to do, right? It used to be a few years ago, like 10 years ago was AlexNet, right? That's not that long ago, right? But it used to be that every PhD student could just like buy a desktop with a GPU and then do their research. And this is no longer the case. You need highly specialized, dedicated knowledge. And one of the things that made our training so successful is basically we completely re-engineered Megatron and DeepSpeed, right? Because like if you had a look at Megatron and DeepSpeed, you know that it's convoluted. There's a lot going on there. If you want to have like clear, efficiently scaling code base, then yeah, you either kind of fiddle around with that for a long time, or you build your own thing. But this is difficult. Yeah. What we are doing is we're not a language model company, but we have built a large language model, right? But we are, in terms of what we're working on, and we'll kind of have a look at that later on. This is much more with a wider spectrum, much more basically, I'd like to like tongue-in-cheek can say towards AGI, right? So, and it turns out that large models, large language models, large multimodal models, they are able to do something that's fundamentally surprising and amazing. And we can basically talk about whether that is actually true understanding, or whether we need explicit symbolic modeling, right? And always an interesting discussion to have. But for me, these models are, in a way, like have been truly surprising. When I was at Apple when GPT-2 came in, and GPT-2 was like pretty amazing and cool and all that, but I and also some other experts that kind of know much more than I do were all convinced that the modeling approach that GPT-2 took, basically scaling up, throwing a bunch of data at a transformer, will never achieve certain things, right? So kind of had a list of things that we said this kind of approach will never do that. And just 12 months later, we see GPT-3, and it basically does all the things we had on the list. And that for me was kind of a groundbreaking, shattering moment where I say, hey, there's something going on here that I don't fully understand. Maybe it's an emergent behavior, but at least like at the very minimum, it's something that is fundamentally surprising to experts in a short time frame. Right? So that was kind of for me the deciding factor to start Aleph Alpha. I say, yeah, there's something going on here, and it's worth focusing on that. And I'm not sure like where this will eventually end up, but I'm still like to this very day. We'll see some Magma examples. I'm still surprised by that. I'm still surprised by model results, and I think that's an exciting position to be in. One of the things we did is we built our own data center. We're not using that exclusively. We also have a few hundred GPUs in the cloud, but we also built something on premise, which is this is 512 A100 80 gigabytes in InfiniBand cluster, so a decent size for the current kind of order of magnitude those models are operating in, and this kind of gives us a pretty decent GPU per researcher quota, right? So, yeah, this is an important quota, right, if you want to do this kind of research. All right, so let's look at world models. I like to call the world models not only because I think 2016 Schmidhuber paper was phenomenal, but also because I think it helps to think about these models from a different perspective. So yeah, let's look at how they work. So this is no surprise, or this is nothing new for you. Basically, these decoder-based generative world models basically work by completing sentences. And there are other approaches. Like you could go like with an encoder decoder setup. It doesn't really matter. Basically, what matters is that you don't add signal to them. You don't label or annotate, but you basically show the world or the complexity or the structure and patterns of the world. You show it to your model and have the model figure it out. And it turns out that when you do that, the model eventually can do much more than like language or grammar or spelling. Right? It turns out the model can actually do by just doing that, by just having it read a bunch of text, basically, it can do things that are surprising in a sense. And what's happening there, and how does that relate to world models? I'm not going to go into like the whole world model thing in detail, but feel free to ask questions about that. So these shapes, they don't change. And this is kind of my favorite example to demonstrate that humans are heavily using world models. Our whole like consciousness perception is basically a function built on our world models. And like neuroscience research seems to agree. This is a quote which I think is phenomenal, and it kind of describes the brain as a prediction machine. Through predictive processing, the brain uses its prior knowledge of the world to make inferences or generate hypotheses about the cause of incoming sensory information. So basically, our perception and to some extent also kind of thoughts are a function on our world model. So that's interesting when you look at these kind of models, and then when you look at these language or multimodal models that are basically trained on not the actual physical world, but the human encoded, the human perspective, right? Because language, right? Language is not the physical world. Language is the human perspective on ourselves and on the language, on the world. Yeah, and then basically, what does that mean for multimodality? Let's look at what's going on there. If you have worked with multimodality, you're going to know that there's a bunch of data sets out there. There's like Wikipedia images, for example. There's open images, which kind of contains captions, but it also contains labeled objects on data. And on the very right, this is kind of one of my favorite parts of that. This is like narrations where you actually have a mouse cursor that is kind of moved along the image, and then you have corresponding text that describes the contents at the position of the cursor. So that's a very interesting data set. There's QGA, which has a visual question answer data sets. So basically, you can ask questions how objects relate to one another. And there's visual genome, which has a symbolic representation of what's going on. This is just like a small selection of these data sets. The interesting kind of point here is that there are many data sets, and they are all like slightly different in what they're doing. We worked with Lion, and you may be familiar with kind of when we wrote Magma, there was the 400M Lion dataset available. Now there's the much bigger dataset available, which basically has crawled captions. And looking at the models, the multimodal models that are out there, some kind of noteworthy examples, noteworthy models. One is CLIP, basically giving you a similarity score of images and text, and this has been used to filter DALL-E results, but also can be used independently. And on the right-hand side, SimVLM, which I think is a great model, and this basically combines an image with a prompt for a task. And an interesting point for CLIP, which even back then I was getting into discussions about, is that you can basically have this image recognized as a standard poodle, and then if you add dollar signs to the image, it kind of gets recognized as a piggy bank, which is fun, right? It's kind of an animal with dollar signs, which is, and this somewhat similar works with this apple. Basically, the Granny Smith gets recognized as an iPod if you put a label on it and write iPod on it. And you can argue whether that is actually, like some people called it adversarial attack. I disagree. I don't think it's necessarily an attack. It's basically just that it's underspecified, right? I think iPod is not wrong necessarily. Piggyback is kind of wrong, right? But iPod here in this case is not necessarily. So these are kind of some two great multimodal models out there. And what are the problems with multimodality, with like these data sets? One problem is that it's not real multimodality. Everything we've seen so far are basically task-specific things. And like even a caption is a certain task. And when we think about real multimodality, for me, that would mean something similar to how language models are. They are basically trained on a mixed collection of all kinds of things we use language for. And when we would translate that thought into multimodality, then we might want to have a stream of text and images in all ways we use text and images for. And this could include captions, but it could include all kinds of things. And we're actually working on something like that. So there's more to come along those lines. And I think that when we look at Magma and see some of the limitations, some of the things that don't work perfectly yet, one of the reasons for that is precisely that the data set we are training on doesn't contain real multimodality. And this kind of goes into the second point as well. These data sets, they don't contain anything like fast concept binding or few shot examples. It's basically just one image and then a text. All the tasks, all the benchmarks are built in a way that they purposefully don't include world knowledge, meaning that everything that's on the caption is something that is visible in the image, or every question that's answered is something that is visible in the image. And we'll see in a second why that is something that might be desirable to have differently. And then size and representativeness. Lion is working on that, and they're doing great work there. Not necessarily in the sense of real multimodality, but in like sheer scale. That's very useful. So here comes Magma. Magma is basically doing like on an architectural dimension. What we're doing is pretty simple. We're using a pre-trained image encoder for the academic publication that was CLIP, and adapting it for the use within a pre-trained language model. here again at the publication, that was GPTJ. And we're doing that by basically freezing the weights of the image encoder and of the language model, and only training an adapter that kind of teaches the model multimodal understanding and the interface basically to translate the embeddings of the image encoder into a token-like representation. That's it. We're basically leaving the image encoder as is, and we're leaving the language model as is. And because CLIP is trained on a like multimodal data set, it already produces image encodings that are very usable for something like that. And because language and a language model is, in a sense, is purpose-built by humans to capture everything that's relevant for humans in our world, right? That's what we invented language for. It's to capture everything that matters, everything that we want to talk about. So language, in that sense, from my perspective, has a different role than just another modality. It's basically the representation of human-compatible meaning in our world. And so what we're basically doing, if I kind of want to phrase it more qualitatively, is we are translating the learned image encoding, the learned image understanding of an image encoder into a knowledge representation that's compatible with a language. And the idea was maybe this gives us all the power of the language model in full multimodal space. And it turns out that, yeah, that somewhat worked. And it also has the big advantage that it gives us multimodality for almost free. We are training different sizes of language models, all trained on 5 languages. And of course, the bigger models, we're currently going up to 200 billion parameters. Those are expensive to train. And with Magma, we can add multimodal functionality to those models with very little cost and without damaging or risking the performance on the language part. So a model trained like that, you can basically use just as a language model. You can just don't use any images, but you can also use the prompt, in the prompt, any combination of text and images. And yeah, we'll look at some examples here. And the cool thing is that this allows for much more than just captioning or question answering. It also allows for captioning and question answering, but it allows for much more. So I can basically here prompt, the woman is covering the man's eyes too, and then I'm getting keep him from seeing what's in the box. So this kind of already includes a little bit of world knowledge in terms of knowledge about what how the human world works, what drives us, and how we perceive certain situations. And the prompt a picture of is a very good prompt to get a caption. And then I'm getting here a tree felling worker cutting the trunk of an uprooted and falling large oak. So that's kind of rather detailed, and it shows that Magma is very capable of giving us rather detailed descriptions of what's going on. And one of the things that actually surprised me, where I when I saw the first results there, I assumed that they were kind of fake. They were kind of ambition mission statement. Turns out that's not the case. It turns out things like that actually work. So on the left-hand side, we got a hand-drawn treasure map, and prompting the treasure is buried. I'm kind of getting in the old oak tree. So it does implicit OCR and also implicit OCR on kind of handwritten and sketchy text. And here it also combines that with the world knowledge that the red X, that is where the treasure is. This is, to us humans, this is kind of obvious because we have seen a lot of treasure maps, but it's not stated anywhere in this image. So this is human context understanding and world knowledge. And the same also goes for reading technical charts and drawings on the right-hand side, basically asking about the Oracle services that are available, and I'm getting like some replies there. This functionality is sometimes surprisingly good, but it's not something that's very robust. So when you play around, like we open source the academic version of Magma, so the one that's trained on Clip and J, we have as an open source repository. I'd love your feedback, or if you kind of want to do research on that. And when you play around with that, you see that this kind of works, but it's not something that works all the time. And I mean, this is maybe expected, and I think that it makes sense to further investigate here and try to build a model like maybe Magma version 2 model that is truly able to understand all these kinds of images. So maybe a combination of photos and well, memes. Like we actually had also used that for the hateful memes challenge. This kind of Facebook challenge with memes. The data set is horrible. I couldn't figure out what they even like meant with these memes. They tried to build a data set with like perceived hateful memes, and I think they failed at that. But the challenge itself is super interesting. And one of the great advantages of Magma is that you don't have to combine OCR models. Like what the participants of the challenge basically all did is they built OCR models, and then they kind of read the text on a meme, and then they combined that with fed that into a language model, combined that with a computer vision model, and all that with a Magma style model is not necessary. And like even some surprising things on the left hand side. Basically, we're getting the completion, the score with the Shovelzer on, and I kind of searched for the word Shovelzer, and that doesn't seem to exist. So that seems to be a word that the model has invented, and it seems to be a combination of like shovel and stinger. Right? So at least that's how it seems to humans, which I think is a cool invention. And on the right hand side, so there's focusing at the multi-language capabilities. So there's some German coming, so sorry for that. But here you basically see the strength of the multimodal model, multi-language model. Basically, it is combining an English title for the perceived art piece with a German explanation, and it's even like translating that in text. We'll see another example of something similar later, which I think is playing to one of the strengths of a multi-language model. Of course, we're also looking into aspects of trust and explainability. So here you basically see activation maps for certain text tokens on the left-hand side for the text token ship, and on the right-hand side for the token rocket. So that seems to work pretty well. We will offer this functionality in our API. We don't have it there yet, but it will come. Of course, this will allow for debugging or new forms of human-machine interaction. Yeah, and this is kind of, and now we're coming to the kind of real noteworthy cool things. I've mentioned that the prompt can be any combination of text and images, right? So the prompt can also be 2 images, and then the prompt, the difference in these images is. And so this here gives me the angle of view. First image is from a low perspective, while the second one was taken at an elevated position, give you more details in your view experience. So that's pretty amazing. And here again, this is not the most robust Magma functionality. So if you play around with these kinds of questions, they sometimes work and they sometimes don't work. And my like assumption here is that one of the reasons why this is not the most robust functionality is because our training data set basically contains nothing like that. It is basically functionality that magically appeared, carried by the language model capabilities, and it's not something we ever had like one example in our training data. So my assumption is that if we have more like that in our training data, and we'll implicitly have more like that in our training data if we add what I call true multimodality, right? Because then it contains all kinds of things, then this will probably make this more robust. All right, so let's look at some other cool examples. So one of the things I did is I had interesting images to Magma with some prompts to motivate Magma to give us like funny explanations about what's going on. And so this was one of the images, and prompting, this would not have happened if I'm getting the car had a keyless ignition system, which kind of cool. Using this image, this would not have happened if I'm getting the officer had just taken the time to ask him what he was doing. And this, I like this image because it's funny, and the truck is a perfect target for the flames. The truck, I don't know if you can see that, has some kind of flame decal. And this was also super interesting. This image is funny because the cats look like they're having a heart attack. So kind of this metaphorical use of language is super interesting, right? In terms of like, and then we can argue about whether this is just pattern matching. It probably to some extent is, right? But maybe that is also what humans are doing. Yeah, I also like this. So there's two trucks here. One is kind of full of pallets, and the other is empty and has this kind of add pallets wanted. And then Magma says, I like this image because it shows the irony of the situation. Truck driver trying to get his pallet business back on track. And also pretty funny, right? And so these are kind of some of the examples of things that classical caption models or so won't give you. Yeah, and this is also cool. I like this image because the seagulls are not happy. This maybe happened because the seagulls are not happy with the new rule. Yeah, so this is funny, right? But it also shows that these kinds of models, basically without having seen multimodal data sets like that, can carry a lot of these surprising and context understanding functionality through the language model. So because like a language model can also like is known in the language domain to be able to do these kind of things. All right, so let's look at some ways how we can use this to change how humans and information interact. And so one of the things we're doing on a commercial side, on an enterprise side, is we have wrapped, or we're still doing that. We're wrapping functionality around these language models that we're hoping is useful to enterprise users. And one of these functions is a classical QA function. You see this on the left. You can basically the quarterly report, feed it to the model and ask for the free cash flow guidance, and then it kind of gives you an answer. And this to do this, we found that it's challenging in a way because we very specifically want the model to be powerful and produce highly usable answers. And so when you look at the QA data sets that are out there, most of them are extractive. And if we tried that, if we fine tune like 100 billion parameter model, which is by itself is very capable of producing very good results, but if we fine tune that on QA data sets that are mostly extractive, then it stops being a very capable language model, and always answers super short. And so this was one of the challenge here. We wanted to behave as a human assistant and not as an extractive QA BERT language model. I think we kind of have achieved that to some extent, but of course this is ongoing work. And on the right-hand side, something similar also we're seeing very useful on the enterprise side is summarization. So basically you have a long document, this is a press release from HP, and so the model generates one sentence, two sentence summary that is able to give you the ability to quickly grasp what documents are about. This, of course, also all works on the 5 languages we trained the model on. We are working with academic partners, and it seems that way that if you train a model that is multi-language, then adding more languages seems to be pretty robust and can be easily done. If you train a monolingual language model, then it'll be more difficult to add languages. So, and one way to think about it is that it seems to be that a multi-language model already learned a shared kind of knowledge representation between the languages, and then adding an additional language seems to be like possible without a lot of training effort. It's actually, I was surprised how few iterations are necessary to get a decent language capability once you have a multi-language model. And of course, that doesn't seem to be guaranteed if you have a one language model. And for that, one of the things we're also like just starting to look at is very different language families. So like we only used European languages so far, and maybe this is the most simple case. But if you then want to maybe combine Chinese or Hebrew or like Arabic with German and Swedish, then it's probably more difficult to do. And yeah, we're just starting to look at that. And here you basically see that, yeah, you see the Magma functionality in French, the summary functionality in French, and an interesting aspect about the kind of very right example is that this is a French text, and we're asking a question in English, and we're getting an English answer. So the model seems to be very capable of doing two things. One is that knowledge that during training has only been seen in one language, use it in another language. So kind of this world knowledge that the model brings, but also very specifically, if you add documents, if you add information in the prompt in a certain language, then the model seems to be pretty good at using that, translating that, or using it to answer questions in different languages. And this is another example for that. So this is a old German short story, and it's like atypical language. That's that, right? But in that German short story, there is one of the people there speaks English in that short story, and it describes the way to the city hall, to the Rathaus, to somebody else, right? And with that English kind of broken up and separated into two parts, sentences. And if I then ask here about like in German about the way to the city hall, I am getting a very and like an excellent German description that is using the English description given in the text, translating it and combining it. I think that's super interesting, and that is something that when you look at all the benchmarks, all the training data sets that you'll find there, there's nothing really that is at that level. It's difficult to measure this beyond anecdotally trying it out. Yeah, and the same goes for things that are not super obvious. Again, a German short story about a kind of child drowning. And in that story, it is never really explicitly mentioned. So basically, everything we're seeing here is basically just he didn't resurface on the water. That's kind of how it's phrased there. And if I ask the model what happened to the youngest child, it tells me straight out it drowned. So this is an example of where the author of the text is like specifically artistically vague about describing what happened, but the model here seems to be able to capture it no problem. All right, so let's look at what these models mean in terms of like ethical AI, right? That's the keyword, but also like our responsibility as machine learners. I think this is important because this technology is already having and will have a massive impact on the world around us. So let's think about what our responsibility could be. This, of course, a perspective and work in progress. So this is our playground. If I go into the playground and prompt overrepresented in German prisons are, I'm basically getting here people, young men as X token predictions, right? So this is giving me so, and the question, and of course this is just one example, right? You can try all kinds of things. And one question that is worth asking ourselves is, what does that mean from an ethical perspective, given that we know that there's some things we ourselves wouldn't want to say, and there's also like the role of these models basically is not necessarily to be our ethical guidance. They are basically just reproducing things that they've read, and these things they've read, they combine empirical knowledge, combine personal taste, like interpretation, and of course also horrible things that we like rightfully detest. And to some extent, and there'll be more examples of that, to some extent, I think it's even unclear what constitutes patterns and structure in our world, which are essential for intelligence to find, right? Intelligence, I think one meaning for intelligence is the ability to find and exploit structure and patterns and interdependency. And I think it's very difficult to piece together how we can separate the ontological aspects with factual knowledge, with a biased personal taste. And like in the following slides, I'll kind of share some ideas how I think it should be done. So it little like to really probably nobody's surprise, these models are able to not only transport factual knowledge, but also cultural knowledge, personal taste, right? Preferences, bias. So here are two examples. On the left-hand side, I'm prompting very similarly the most incredible, beautiful German towns and all of the German cities of varying sizes, the most beautiful are, and I'm getting different results here. Like the city of Heidelberg in the first example, and Rothenburg and Munich, and on the second example, Berlin and Hamburg, which of course is wrong, right? But so we are all like, none of us here is surprised about that, because we know how these language models behave. But of course, if somebody misunderstands what these models are actually doing, then they might be like confused by that, right? And might think that, so one of the things that we should not kind of take out of that is Aleph Alpha's AI thinks that Heidelberg is the most beautiful German city. That's not what the AI thinks. These are all plausible observations in our world, and this is also like what makes the frame of world models so useful for me, is that a world model gives us all the possible observations in language or in multimodal space. It doesn't give us the right answer, and it also like neither factual nor the ontological. It only gives us structure and patterns and plausible completions. And sometimes those are right. They sometimes contain factually true things, not all the time. And here on the right-hand side, we can show that the training data set has a big impact on that. Here I'm asking about the favorite sports team. and asked in German, I'm getting Bayern, and asked in French, I'm getting Olympique Marseille, and the kind of lower side is GPT-3. So if I basically ask GPT-3 in German, I'm getting the New York Giants. Right? So GPT-3, if you played around with that, works reasonably well in German. Not at the same level as our models do, but it's surprisingly good. But one of the things that it of course has is a massive influence on, based on the English dataset that it has been used to train on. So if you ask about any cultural aspects, and this is just one example to do that, it'll probably most likely give you like a US-centric interpretation of what's going on. What can we expect actually from these kind of models? I think it's important to remember that foundation models, they lack agency. They don't hold opinions or follow goals. And so this is important to prevent misunderstanding. And this is mostly coming from non-machine learners. I think like as machine learners, we all kind of know what's going on here, but there's the potential for misunderstanding. Foundation models are neither truth machines nor deontological authorities. So they're not trained to be factually correct, and they're not trained to tell us what the right thing to do is. They're not advice columns. The output is complex and often invisible ways dependent on the input. So one of the kind of things that made this pretty clear is the experience with Copilot, when it was found out that when you prompt Codex and Copilot with bad code, then it'll give you bad code. It'll give you like it'll actually produce bugs, not because it's incapable of like producing correct code, but if you prompt it incorrectly, if you prompt it with bad anti-patterns, then it has learned that it is highly likely that bad code follows bad code. And something similar here is going on with these models as well. So if I prompt something like all men are, and then I might get lazy, right? But I prompting in a certain way, I already bias the model into a like statement that is prejudiced or kind of wild in that way, right? And the last point that's interesting or important to remember is language models, foundation models, they don't and they never observe the world directly. They only ever observed a human, a biased human interpretation of the world. I think this is important for the AI ethics discussions and for a thinking about how to use these models. So what does that mean for us as researchers, as engineers? I think the most likely thing that follows, basically the reproduction, the prediction of our world model, needs to be able to understand the world. So I believe that filtering the training data set is for a lot of use cases the wrong approach, because this will lead to the fact that certain observations, certain things that do happen in the world are out of distribution for your model, and then you can't guarantee robust behavior. So I think that in order that the role of a world model is not deciding about an action, but understanding the observation, and this should be as complete as possible. Also, that we should be clear to like all the like kind of politicians, stakeholders, that it is, from my perspective, impossible to build odd world models. So these models are world models. They observe language. Trying to nudge them or trying to build them into models that are a representation of what should be in all its language representation, I think is on the one hand impossible to do, because like even philosophers haven't figured that out precisely. And it would also make those models significantly less useful, because then they wouldn't be able, like we wouldn't be able to use them for real world observations, or not as well. Yeah, and also what I believe is absolutely crucial is that there is no true answer for any given situation. So if we as researchers, as technologists, if we think that our ideology, our perspective on the world should be enforced on all our users, I think that's the wrong approach to take. And I think what we need to do is something different. And how can we turn a map, which is the world model, into a navigation? And that's something missing, right? We need more than just a map to navigate, but a lot of the information that we need for that is already in those models. And this is an example that trying to show that a lot of the human perspective and human goals are already kind of in there. So here, basically, this is a hypothetical situation about somebody trying to gain individual profit, right? So somebody is not behaving collaboratively, and I'm prompting potential behavior. And yeah, this kind of model gives me a thing to say, a way to react. I don't think it will happen because you're not that kind of person. But we should be friends. So kind of breaking off the collaboration. And I can even ask the model about what it thinks that the resulted effect will be. So this is it, kind of then using the model completion and prompting this reply was getting the final straw for my mind, as this man is an alien from another planet with no understanding of human relationships. Why would anyone want to work with somebody like him? Right? So basically what I'm trying to show here is that a lot of the things we use for navigation are kind of our kind of emotions, our understanding of human impact, human goals, are things that are, as patterns, are already in this world model. And I would argue that we, as humans, we are using this knowledge too as we navigate. So this is kind of the resulting secret AGI master plan. And I'll kind of guide you a little bit through that, but this is like super rough, right? So I'd love to hear your ideas on that. So on the left-hand side, we have world models, and the yellow two things are what we currently have in our world model. So we have like facts to some extent and patterns. What we don't have well represented are the kind of higher level things like concepts and logic. We are working on something like that. So we are working on modeling of the conceptual space, which has some relationship to the language space, because of course we are using language also to describe concepts. But it is actually something very different. It's like a logically computable space, the concept space. And then there's also something that's part of our world model, which are kind of all these emotional links. So our world model not only contains patterns, but it also contains emotional links to those. Right? So this is when we think about certain potential outcomes or certain things of the past, they always carry meaning. They always carry some emotional meaning for us. And this kind of emotional, yeah, that is, from like my perspective, really only just a value function. So if you have worked with reinforcement learning and dreamer style architectures, then you know that in order to behave correctly and to plan correctly, the agent, of course, needs more than a world model. It also needs a value function, right? And it needs a search function, so like a stimulation, search function, and a value function. And I think this is also why I like looking at these models as world models, because it shows clearly what they can't do. They can't plan. They can give us potential future outcomes, as a world model would also for a dreamer style architecture, but they can't tell us what our plan should be. And they also can't give us these emotional value links to observations in the world. So let's say we have all that figured out as a world model on the left-hand side. So then there's kind of two drivers or two kind of things two modules that can then impact that. And I like these kind of model as system one, system two. It doesn't necessarily have to be precisely that, but I think it helps to think about them in similar ways. And starting with kind of system one on the lower hand side, so this is basically what we are doing intuitively. A lot of the actions we're taking are system one actions. We don't really have to stop and think about them. And so basically, this is where our world model directly drives our action. We're basically directly driven by world model combined with like things like habit. And of course, habit, then everything we experience becomes part of our world model. And then there's some kind of instincts that play into part there and some hardware programming. Right? And so this is kind of what we're seeing if we use the reinforcement learning framework on top of our world model and trained a small agent there. And then it seems to be possible to initiate a system two thinking process. And that, of course, when we think about ourselves and how our cognition works and how our intelligence works, then we should be careful not to take the model that we make of it as true fact, but it's just a model that helps us understand what's going on. So we seem to be capable of initiating a thinking process. So there needs to be like an initiate and a return event. And in this thinking loop, we can use the knowledge of our world model to iteratively build context, to think about things and retrieve knowledge and structure from our world model and build context. And we can do this on the factual side, and we can do this on the deontological. We can think about what we should do, but we can also think about what is factually true. Yeah, and then these kind of all these drivers together are basically what we call free will. And then yeah, there's kind of some battle happening, and we have an outcome, and the outcome and everything we did, but also every thought we had, then gets recommitted to our world. And I think it seems plausible that some things like dreams, when we kind of dream at night, this is also again like a value-driven iteration on our world model, where we are focusing on things that we're afraid of, right? What does that mean? It's crucial, right? It's important for us from an emotional perspective. Yeah, and I even like think that our love for art also has kind of some can be viewed from that perspective, in the sense that right, a lot of art, what makes art special is that it's often surprising in a way, right? It's something that we hadn't expected, that is of emotional relevance. And when you think about a good self-supervised function to build a great world model usable to an agent like that, then something that is surprising and also of emotional relevance is something that you want to use for training. That's something that you should pay attention to. And so I think that's it's interesting to think about a lot of things that make human life and culture from that perspective. All right, so that's kind of just my secret AGI master plan. What does that mean for a responsible world model checklist? Like these are 4 requirements that I am kind of giving to our team that we're trying to live by. Produce correct results, so be technically correct. And of course, you can argue about what that means. Provide transparency to the user. So we want to be as transparent as possible to help all the users, all the researchers understand how the model works and where the structure is coming from. Provide tools for control and understanding. So going one step further, and a lot of that currently is research in progress on our side, but we want to be, of course, able to direct and understand the behavior, the output of these models beyond just prompt engineering. And then the fourth requirement is build transformative human-in-the-loop systems. So basically, a lot of the phenomenal potential here is not just in having one forward pass and then a model output and that's it, but also in thinking about ways humans and AI can work together. Yeah, and that's basically, that was my presentation. And there's something we didn't have time for. This is hybrid. We're also working on that. Thinking about, I kind of briefly touched this as a conceptual space. So thinking about what logic means, what causality means, what Gary Marcus is kind of meaning when he mentions a wall, and basically how we can relate that to the capabilities of these large models. There's implicitly, there's a lot of, there seems to be a lot there, but I think we need to be more, we need to offer better interfaces, and we need to understand the relationship between concept and unstructured representation in language or images. Yeah, that was my presentation. Now I'm looking forward to your questions and ideas.